On section 7.2, our lesson today is on converting parametrics back to rectangular, which is similar to what we did when we were in Unit 6. We had polar equations and we had to get it back to rectangular. So when we look at this, it's going to be that same mentality, that same idea. What we want to do is get y by itself in the end. But first thing we're going to look at is the steps given at the top of the page in your notes. It says convert a parametric, follow these steps. What you'll notice though is the very first thing you do is not do any algebra. The first thing you do is graph this on your calculator in parametric mode and then estimate or get some idea what the graph is going to look like in rectangular mode. You might have a straight line, you might have a circle, you may have a parabola, or you may have something that isn't recognizable in rectangular form, but at least you know that going in. So step one is always go parametric mode in your calculator, graph it, and then from there be looking for, it gives you a target to be aiming for when you do steps 2 through 5. If that is the case, we just dive right into question, example 1 here. We would graph x is t plus 1 and y1 as 2t. So let's go ahead and do that. T plus 1 and 2t. So again, real quick, in our mode, we are in parametric mode. Radians, I suppose, between radians degrees, I'd stick with radians for now. I'm also in simultaneous mode, so anyways, y equals, would we say that was t plus 1? So again, t is just that variable button, just like we would enter an x, plus 1. I'll hit enter, and then we have 2t, so y equals 2t. So let's graph that. What we'll find is our window, because we're in radian mode, the t, min, and max is for some reason set in a radian style. It's set to 0 to 2 pi. So I'll actually evaluate that at negative 10 to 10. T-step, I'll just a rounded 0.1. Right, so if we graph that now you can see what it really looks like. But it's a straight line and positive slope. It looks like it crosses the y-axis -2 and x at 1. So let's go back. So we crossed at -2 and we crossed at 1. So that's kind of that idea of step 1. From there, the key, the real meat of this unit is steps 2 through 4. So step 2, what you're supposed to do is, in order to get from a set of equations x and y with respect to t, we want to convert those, substitute, and eventually get y equals something. See, I got a little bit of room there. So in the end, we want this thing to say y is equal to something. Right? So we'll eventually box in something like that. The steps, as described in that box up above, so we did step 1, check. Step 2, solve one parametric part, either the x or the y. We solve it for t, and then in step 3, we substitute that into the other one. So what that says is, find one of these, x or y, and solve it for t. For example, if I solve my first equation, my x equation, for t, I would just subtract 1 from both sides, and I'd get x minus 1 equals t. And then step 3, it says substitute that t value of x minus 1, sub that in for the other part being the y equation. So now I say y equals 2 times t, and this is where we say, well, t is actually x minus 1. And therefore we can simplify. I suppose we could actually end here, but we want more of that, mx plus b, so we get 2x minus 2. So that's as far as we can go. Y equals 2x minus 2. Well, let's check. So y-intercept -2. Our slope is 2, so we went up 2 to the origin and over 1. All right, so it really is as simple as that. Substitute to find t in one of the equations, and then solve by subbing that t into the other equation. Eventually get y by itself, and we're done. Let me do number 2 here. And in 2, if I have to, I can divide to get t by itself. Like in question 1, it was easier to just subtract the 1 across than to divide by 2. In this case, I would actually say and argue that it is easier to divide by 6 on both sides to get t by itself than it is to solve the x variable equation for t. But it doesn't matter. You can choose either one. I'm going to choose to solve the y equation, solve it for t, plug it back into the x equation, and then solve for y. In other words, I'm saying I'm going to say y over 6 equals t. The first step is solve for t. And then I'm going to rewrite my x equation with that new t. The t squared becomes y over 6 squared. And this is where we say that simplifying process, right? Step 4, simplify and get y by itself. Okay. So I've got x minus 5. X minus 5 is equal to negative y squared over 36. I'm going to multiply both sides by multiply by negative 36. If I multiply this side by 36, I get y squared by adding the negative to my multiplication. Now, this is where you got to be careful. The last step, if I want y by itself, I am going to take the square root of y squared. And that's fine, it's legal. What we do to one side, we do to the other. So we say that the square root of this left side is equal to y. But when we do that, we have to be careful, because by taking the square root of this, a y squared graph will be a sideways parabola. If I look at graphing the square root of this stuff here, we actually only get half of a parabola. So anytime you take the square root of a term, like y squared, the answer needs to say plus or minus the square root of, and then whatever was inside. Okay, and then that looks like that. Now, I did skip step 1, graph this on the calculator, so let's do that now. Clear that. So x1 was just 5 minus t squared. And that was just 6t. So there it is. That, like I said, a y-squared graph is sideways parabola, so that does check out. But we're going to go 1, 2, 3, 4. So we're going to go to 5 over, okay. And then from there, let's see. I can't, I'm trying to figure out what the y-intercept would be, but it's not that critical. What's critical is that we show that we have a sideways parabola. Again, don't mark those y-intercepts exactly. I could find the numbers, but the most important thing is the algebra and getting y by itself here. That's enough for this video. I'll do another one to finish up some of these examples, and yeah, and then we'll be done with 7-2.